Okay, if you can hear me, please type yes. Looks like Sandra and Robin can hear me okay. Very good. All right, we're going to start. This workshop is about exponents, part 1. Let me make sure that everybody have the handout. If you have the handout, please type OK or yes. Robin, you have the handout, and Sandra, both of you have a handout. Great. Okay, before we start the handout, let's go over some of the basics rules. Okay, the first one, we're going to talk about the product rule. When we have a to the power of m times a to the power of n. Now, before we look at this, let's take a look at the example. As usual, remind you that if you have any questions at any time, please raise your hand. So if I have 2 to the power of 2 times 2 to the power of 3. Now, Sandra, what is 2 to the power of 2 consist of? How many 2's we have here? Can you type for me? 2 to the power of 2 means how many 2's do we have? Sandra? Okay, yes, 2 to the power of 2 is equal to 4, but it means we have how many 2's? It means we have, Robin, you want to type how many 2's we have there? We have 2 2's, right? Sandra, you said 5. Well, you said 5. 2 to the power of 2, it means we have 2 times 2. Is that okay, Sandra? I'm not sure where you get 5. I think you're thinking about the final answer. Yes. Okay. Before we get to that, how about 2 to the power of 3? 2 to the power of 3 similarly would be equal to 2 times 2 times 2. The rounds up okay so far on this? Everybody follow that? It should be a very simple concept. Yeah. So as you see, we have, how many 2's do we have here now? We have 1, 2, 3, 4, 5 2's. So the answer, exactly, the answer should be 2 to the power of 5. Just by looking at this example, that's pretty obvious. So the product rule that we have, a to the power of m times a to the power of n, looks like that we are keeping the base 2, we're keeping a, and then to receive 5 from 2 and 3, looks like we're adding the exponents. So Sandra, can you tell me what should I put at for the exponents here for the product rule? A to the power of m times a to the power of n would be a to the power of what? What should I put up top here? You put mn. That's not quite right, because mn would be product of those two. We didn't multiply these two. Robin, do you want to try? M plus n, exactly. So we keep the base a, looks like that in this example, and we add the exponents. That should be m plus n. Okay, great. So you can follow that. So I can give you another example. So when I have x to the power of 2 times x to the power of 5, according to this rule, the answer should be x to the power of, Sandra, what would be x to the power of what? 7. So we're adding 2 and 5, and we would get x to the power of 7. Okay, rounds up okay, everyone, please, if you're okay with this concept. Okay, very good. So let's take a look at a power rule. Okay, let's see. Elaine joined us. Elaine, can you hear me okay? Please type yes if you can hear me. Very good. Okay, very quickly I'm going to go back, since Elaine joined us, if you don't mind, everyone, to quickly go over what we covered. Elaine, we looked at product rules. When we have a to the power of m times a to the power of n, that would be equal to a to the power of m plus n. We add the exponents, and before that we looked at this example. If we had 2 to the power of 3 times 2 to the power of 2, then we broke these into its prime number. 2 to the power of 2 consists of 2 2's. 2 to the power of 3 consists of 3 2's. And then it looks like we are adding the exponents. We get 5 2's. And we looked at another example, x to the power of 2 times x to the power of 7 should be equal to x to the power of, x to the power of 2 times x to the power of 5 is equal to x to the power of 7. Elaine, can you type okay if you're okay with this concept? All right, great. So let's move on to the next thing. We were talking about the power rule, and that is when we have a to the power of m, and then the whole thing to the power of n. Let's take a look at the example again. If I have 2 to the power of 2, and then raise this to the power of 3. Okay. Now, we talked about what 2 to the power of 2 means. If I break 2 to the power of 2 into its prime number, we would get 2 2's out of this. 1 2 here, 1 2 here, and then would be whole thing to the power of 3. So in this case, the exponents here would be 1. So each of these should raise to the power of 3. So we have 2 to the power of 3, 2 to the power of 3. So in this case, I would have 3 2's, 1, 2, 3. And over here, I would have also 3 2's. So how many 2's do I get here? Elaine, can you tell me how many 2's I get total? Looks like I get 2 to the power of what? I have 1, 2, 3, 4, 5, 6, exactly 6. So looks like we keep the base here, and what are we doing to 2 and 3? Anyone? Robin, Elaine, Sandra, tell me, any of you, what are we doing with number 2? We multiply, exactly, we multiply 2 and 3 together, and that's how we come up with 2 to the power of 2 times 3 is equal to 6. So in this case, for the power rule, I can say I can keep the base A, and then Robin, can you tell me what should be there at the top then for the exponents? That would be, no, in the power rule, we have M and N. What do I have to put here? I should write exactly M times N now. M times N. That's correct. So if I look at another example, so if I have b to the power of 2 to the power of 8, all right, Sandra, can you tell me what would have here? Or would be b to the power of what? B to the power of, Sandra, that would be b to the power of what? You put 10. I'm not sure why. 16, that's correct. You multiply 2 times 8. Okay, rounds of okay for this concept, please. Robin, Elaine, Sandra, your call. Everybody okay? Very good. Okay, so we're going to look at another one. This is also would be a power rule. Let's just call the other power rule A, and we'll call this power rule B. Slightly different, very similar though. This one, when I have A, B to the power of M. Now remember, when we don't have any exponents at the top of these variables, that means the exponent is 1. So you can put the imaginary 1 here if you like. Based on what we learned on power rule A, part A, we were supposed to multiply the exponents. So if I recall part A, then I have A to the power of M to the power of N. We agreed that this would be A to the power of M times N. So if I had M equal to 1, so in this case, that would be A to the power of 1 times N, or just simply A to the power of N. Or if I had A to the power of M, then that would be A to the power of 1 times M, which is equal to A to the power of M. Now, rounds up okay if everybody agree and understand this power rule part A that we mentioned. Good. Okay, so if this is true, we can come up with the power rule part B and write this as A to the power of, okay, Elaine, can you tell me the exponents for A then, what that would be? That would be A to the power of what? M, exactly. And that would be B to the power of, it's like multiplying M times 1 would be M, and multiplying 1 times M here for B, also that would be equal to M. Okay. Rounds up okay for power rule part B. Okay, let's take a look at the example of this. If I have 5n to the power of 2. Okay, Robin, can you tell me what this would be equal to? Okay, put 52. I'm not sure what is with 52. And then you say no, so you want to change your answer. Oh, you mean, I'm sorry, yes, yes. You have 5 to the power of 2, exactly, times n to the power of 2. You're absolutely correct. Okay, so it means 5 to the power of 2 would be equal to 25, right? 25 n to the power of 2. Okay, please type OK if everybody okay with this. All right. Now we're going to take a look at one more. Power rule. Well, let's call this part C. This is where we have A over B to the power of M. Again, this would be very similar if you can imagine. If you can imagine, the exponents here are 1. Similarly, then we would have A to the power of Elaine would be A to the power of what in this case? 1 times M would be M, and B to the power of M. Example for this would be if I have 2/3 to the power of 2. Okay, Sandra, can you tell me what this would be equal to? Exactly, 2 to the power of 2 over 3 to the power of 2, which is equal to 4 over 9. Very good. Rounds up okay so far for all these concepts? Good. Now, we could have a combination of these rules. Let's take a look at one. We're going to combining all these rules we learned so far. Let's say we want to evaluate 2a to the power of 2, c to the power of 1 over b to the power of 3. The whole thing is to the power of, let's say, 3. Look, I see Mariam is joining us. Mariam, can you hear me? Please type OK if you can hear me. Great. All right. We are going to use all the rules we learned so far to evaluate this. So that would be a good time to look at all the rules, and also since Mariam joined us, I can kind of review all that. The first rule, that was the product rule, we looked at. Then we have a to the power of m times a to the power of n. That should be a to the power of m plus n, and we look at the example where we had 2 to the power of 2 times 2 to the power of 3. 2 to the power of 2 consists of 2 2's here. and 2 to the power of 3 consists of 3 2's, and looks like we are having 5 2's, and looks like we're adding the exponents when the base are the same. Mariam, could you type OK if you're okay with this concept? Good. And then we looked at 3 different types of power rule. The first one, a to the power of m, then to the power of n, and we look at the example. 2 to the power of 2, the whole thing to the power of 3 means we have 2 2's here for having 2 squared, and then each of those get to the power of 3, and then out of those we get 3 2's each, and then looks like we have a total of 6 2's, and it looks like that we are multiplying the exponents. 2 times 3 is equal to 6. So a to the power of m to the power of n would be equal to a to the power of m times n. Mariam, could you type OK if you're okay with this concept as well? Okay, and then we looked at power rule part B when we have a b to the power of n, and we'll put the imaginary one here. That's the reason the exponent is not there, because it's 1, and it looks like we are multiplying the exponents together. So here would be m times 1 would be equal to m, and so on. And we look at the example, 5n to the power of 2 is the same as 5 to the power of 2 times n to the power of 2, so that would be 25 n to the power of 2. Mariam, type OK if you're all right with this concept as well. All right, and the next thing we looked at was the power rule when we have a over b to the power of m. Similarly, that would be like we're multiplying 1 times m. That would be m here, and so it would be a to the power of m over b to the power of m. And we looked at one example. 2/3 to the power of 2 is the same as 2 to the power of 2 times 3 to the power of 2, which is equal to 4/9. Mariam, type OK, please, if you're okay with this concept as well. Good. Now, everyone, I want you to use the combination of these rules that we looked at to tell me what we have here. Okay, I'm going to start with Elaine. What would happen to the 2? That would be 2 to the power of what? Elaine, 2 to the power of 3, exactly. So since we can put a 1 here if you like, 1 times 3 would be equal to 3. Okay, rounds up okay with this one, everyone? Would you follow that? Type OK if you would be okay with this. Okay, Sandra, you said no. Okay, let's take a look at it. This part, 2 to the power of 1 to the power of 3. Let's just take a look at this part by itself. If I have 2 to the power of 1 and then raise it to the power of 3, would you agree that I have to multiply these two together and I would get 2 to the power of 1 times 3, which is 2 to the power of 3? Sandra, are you okay with that part? Yes, so do you see that why we have 2 to the power of 3 here? We're simply multiplying. This 3 belongs to all these exponents, including this 1. Okay, type OK if you're okay with this part, Sandra. All right. So similarly, why don't you tell me, Sandra, what would be the next one? Would be a to the power of what? Remember, this 3 also belongs to this 2 also. You have to, the product of this 2. Okay? Sandra, you said 1. I don't understand what 1 means. Sandra, we have, let's bring it out here again. If I have a to the power of 2, and then the whole thing to the power of 3, you see we have to multiply these two together, right? That would be a to the power of what? 6, right? 2 times 3 would be a to the power of 6. So here, similarly, I should have a to the power of 2 times 3, which is 6 then, right? Type OK if you're okay so far, Sandra, with this. All right. Now, let's see. Maryam, can you tell me what would be the next one? That would be c to the power of what? Again, you can put the imaginary one here if you like. And this 3 belongs to that as well. You put 3. Very good. So that would be c to 1 times 3 is equal to 3. Now, rounds of OK with everyone if we can follow the top. Very good. Okay. Robin, can you tell me what would be the denominator? B to the power of what then? B to the power of what, Robin? 9. Okay, Sandra, do you get that also? Do you see why it's 9? Type yes if you can follow it. Okay, good. So 3 times 3 is equal to 9. All right, we did it. Can I combine anything here? Put can if you think you can combine. Cannot if you cannot combine. Okay, so Robin, you says you can combine. What can we combine here? Robin? Okay, Sandra said cannot. Elaine says cannot. Robin, you said can. Robin, what can we combine here? Oh, okay, yes. Yeah, exactly. 2 to the power of 3, we can replace it with 2 times 2 times 2, which is equal to what? That's what you meant. 8, yeah. We can change that to 8. But we cannot combine the rest of these. Everybody agree with this? Why can we combine the rest of these? Somebody, can you tell me why cannot we combining? In your own word, tell me why cannot combine any of these? Okay, Sandra says no like terms. No like terms, no like terms. Yeah, because the base are different, right? Right, Robin, you were simplifying. That's correct. So I cannot combine those. When we get to exponents part 2, the next workshop, we'll talk about more about how can we combine these when they're in different form. For right now, obviously that would be our final answer. Okay, Sandra, you're asking how we get 8. Okay, what is 2 to the power of 3? Okay, Sandra, what is 2 to the power of 3? Isn't that equal to 2 times 2 times 2, which you said 8, exactly. So do you see why we get 8 then? Okay, good. Now, I want everyone to take your handout out. Now, I asked earlier about the handout, but let me ask again. Elaine, do you have the handout? Good. Marianne, do you have the handout? Good. Robin, Do you have the handout? And Sandra, I believe you said yes too. Okay, so everybody, the handout. Let's take a look at the first part of the handout. It's very simple. When you're done with the first page of the handout, which is problem 1 through 9, I'm sorry, problem 1 through, okay, there are 3 problems on each of those rules. So it's 12 problems actually on the first page. When you're done with the first 12, please type done. So I know you're done with the first page, and we'll review them, and then we'll look at the second page. Okay, if you type okay, if everybody understand the instructions and they're okay with it. Robin, you okay? All right. So I'm going to pause until I hear from you. Just type done when you're done with the first page, please. Okay, looks like everyone done with the first page. So let's quickly go over the first one. Elaine, the property again, a to the power of m times a to the power of n would be a to the power of what? A to the power of, Elaine? M plus n, exactly. We add the exponents. We talked about that. Okay, so the first one should be x to the power of, let's start with Mariam. That would be x to the power of what? You put 13, right? 9 plus 4, which is equal to x to the power of 13. That's absolutely correct. Robin, second one, that would be m to the power of what? — 7 plus 8 is equal to 15. That's correct. Okay. Sandra, next one would be minus 5 to the power of what? Sandra? You put 6. That would be 2 plus 4 is equal to 6. Now this answer would be, this question is for everyone. Use your calculator and tell me what would be the answer here. Negative 5 to the power of 6. What number do you get? Elaine, Maria, Robin, Sandra. What number do you get using your calculator? You have to multiply 5 by itself 6 times. Actually, you have to multiply negative 5 by itself 6 times. Robin, you're giving us this number, 1,000, okay, 15,625. Okay, is it positive or negative? Positive. Again, can somebody tell me why this is positive, not negative, in your own word? Evenly multiplied. Yeah, we have even numbers of negatives here. So we have negative multiplied by itself 6 times. Since 6 is even number, the answer is going to be positive at the end. Okay, rounds up okay for these 3. All right, let's take a look at the next one. All right, Sandra, can you tell me what would be the rule here? That would be a to the power of what? Sandra, if you have a to the power of m to the power of n, that would be a to the power of what? Sandra? mn. Yeah, we multiply. Okay, so Robin, the first one would be a to the power of what? 5 times 2, 10. That's correct. Mariam, the next one would be b to the power of what? Did you put 8? Mariam, you want to correct it? B to the power of 24. Yeah, you multiply them. And Elaine, last one would be 3 to the power of what? 4. Okay, very good. Rounds up okay for power rule part A? All right. Part B, Elaine, you want to tell me what's the rule here? That would be a to the power of what? Good. A to the power of m times b to the power of m. Exactly. Mariam, so this one would be a to the power of what? Mariam, 4, b to the power of 4. Very good. Okay. Robin, next one would be x to the power of, obviously, 10. Y to the power of 10, z to the power of 10. And, okay, Robin, I didn't hear from you last one. Well, how about the last one? Robin, you want to tell me what would be the last one would be? Robin, what is number 3 would be? Yeah, 7 to the power of 2 n to the power of 2, which is 49 n to the power of 2. Very good. All right, rounds up okay for that one, please. All right, the last part, that would be a to the power of m. We talked about that over b to the power of m. So the first one would be a to the power of 7, b to the power of 7. This would be 4 to the power of 3, h to the power of 3. We can change that to 64 to the power of h to the power of 3. And this would be 2 to the power of 2 over 5 to the power of 2, which is equal to 4 over 25. Okay, rounds up okay for all these, please? If you have any questions, now is the time to ask. Okay. How many of you are done with the second page? Can you type done second page so I know? Robin. Sandra, do you have a question? What's your question, Sandra? Okay, Mariam, you're working on the second page. Okay, you can continue on that. What's your question? Sandra, you got it? Okay. Okay. Let me give you a few minutes for everyone to finish the second page and we go over them together. Okay, I see Mariam is working on the second page. Robin is done. Elaine is done. Let's see. Sandra, you're working. Okay, 2 done. All right. How about problems 1 through 3? Everybody done with problem 1 through 3 on the second page? Type yes if you're done with the first 3. Elaine, Robin, you're done. Sandra, you're done. Mariam, no. Okay. Mariam, when you're done with the first 3, just let me know so we can work on those. Okay, let's take a look at the rest of these. Elaine, can you tell me what would be the answer, the final answer for the first one? What do you have? 1 over what? After you combine them, yes, you have 1/2 is your base, and you add the exponent, so it would be 1/2 to the power of 5. You can write this as 1 to the power of 5, 2 to the power of 5 also. That would be 1 over 32 if you like. Rounds up okay for the first one, please? Sandra, you don't see that? Okay, let me see. Elaine, you're okay. Sandra, multiply. Okay. You see how we have the rule that we looked at, a to the power of n times a to the power of m. Sandra, can you tell me what is this equal to? A to the power of what? Sandra? If the base are the same, what do you do with the exponents? You add them, exactly. So isn't it true that the base are the same here? 1/2. Instead of a, you have 1/2. So that's why you add the exponents. Do you see that? Okay, good. All right, the second one. Okay, Sandra, tell me, what is the second? What's the base for a second one? The same base. Your a is what? 4v. And then, no, your base. What's your base in this case? You said 4. No, not just 4. The base is another variable attached to that. What's the base? 4v, exactly. Now, what do we do with the exponents? We add them, right? Good. So we have 4v to the power of 8. Now you can write 4 to the power of 8, v to the power of 8. You can actually go ahead and write 4 to the power of 8, use your calculator, write what it is. But this is good enough. Rounds up okay for number 2, please? Okay, Marianne and Robin, are you okay with number 2? Okay, Sandra, we cannot leave it as 4v to the power of 8 because the exponents for 4 is 1, the exponents for v is 1, and remember we were supposed to multiply these. Remember the second, yeah, good. So the second one we had was a to the power of n to the power of m. Here we multiply. So that's what we do here. All right. Next one, let's see. Mariam, can you tell me what would be the base for a number 3? What's the base? What's your a in this case? Negative 2t, exactly. And then, what would be the exponents then? You have to add them. So this would be 1. So it would be, you put 2. Why you put 2? Mariam, why you put 2? Don't you add the exponents? One exponent is 2. The other one is 1. So you have to add them. 2 plus, don't forget that this is 1. So rounds up okay up to this point. Everybody okay up to this point? Elaine, you're okay? Robin, okay? Sandra, you're okay? All right. So if I were going to expand this, what do I have? I have negative 2 to the power of 3, t to the power of 3. So what would be the results here? What's negative 2 to the power of 3 is equal to? Okay, Sandra, you said 9. Why do you say 9? Sandra, where did you get 9? Negative 2 to the power of 3 is the same as negative 2 times negative 2 times negative 2, isn't it? So that would be negative 8 t to the power of 3. Okay, rounds up okay for the third one, please. All right, I'm going to move on to the next one. In this case, Elaine, can you tell me what we have? The exponents here is 1. You can put 1 here. The first one would be d to the power of what, Elaine? D to the power of 8, exactly 1 times 8 is 8. And then e to the power of what? 2 times 8 is equal to 16. So we, according to what we had before, a to the power of n to the power of m, we multiply the exponents, and that's exactly what we're doing. Rounds up okay for number 4, please, everyone. All right. Maria, for next one, that would be, again, you can, if you want to put the exponents of 1 on top of 2, so that would be 2 to the power of what? 2 to the power of 3, r to the power of what? You multiply them, 15, and s to the power of what? 12. Okay. Rounds up okay for number 5, please. All right. Robin, can you tell me next one here? That would be m to the power of what? You multiply 3 and 4. That would be w to the power of what? 12. And then we have w to the power power of 2 times 8, which is what? 16. And now we have to add these, right? We can use any variables we want. The base are the same. We add the exponents. So that would be w to the power of what? 12 plus 16 would be w to the power of 28. Very good. Okay, rounds up okay for number 6, please. Okay. Look at the last ones. Okay, let's see. Elaine, can you tell me what do we get for the first part here? I'm going to put the exponents of 1 for the one are missing. Just remind yourself these are 1. So that would be 3 to the power of what? 3 to the power of 2, right? And then f to the power of 2 also. Very good. Not f to the power of 2, yeah, okay. The second one, second parentheses, we have f to the power of, okay, Elaine, continue, 4, h to the power of 4. Good. Now, can I combine any of these? Elaine, can I combine any of these? Yes. Which one can I combine? I know this is 9. Right, we can combine these two as f to the power of, Sandra, that would be f to the power of what, Sandra? 6, right? Add them. 2 plus 4. Good. So that would be 9 f to the power of 6, h to the power of 4. Very good. Okay, Mariam, this would be 7 to the power of what? 6. Mariam, please respond. 8 to the power of what? 4 and 6, 24, you multiply them. C to the power of 2 times 6 equal to 12. Very good. And then you have b to the power of what? 5 times 6 is equal to what? 12. What do we get? 5. And how about the b, Mariam? 30. Okay, so far rounds up okay for up to this point. Everybody okay with that? All right. Now, can I combine anything here? No. Great. I can leave 7 to the power of 6 as is. That's fine. All right, the last one. Sandra, we have 5 to the power of what? 2. J to the power of what? 10. Good. And k to the power of what? 6. M to the power of 2. And then continue k to the power of 3. And m to the power of what? 15. Good. Can I combine any of these, Sandra? Well, this would be 25. Yes. Which one can I combine? K, exactly. Now, J is all by itself. I'm going to record it here. K. So let's look at the K. You have 2 of them here. So that would be k to the power of what? Sandra, k to the power of what? 9. Okay, can I combine anything else? M. So that would be m to the power of what? 2 plus 15. Okay, 17, that's a better answer. So Andrew said, yeah, good. You corrected yourself. All right. Rounds of okay for this one, please. Okay. As you know, you need to turn in this handout to my office to get the credit for your workshop. You can slide it under my door when you're on campus. Type no if you don't have any questions on what we talked about. Robin, you're okay. Len, you're okay. Sandra, you're okay. Mariam, how about you? Do you have any questions? Mariam? Oh, you have a question. Okay, what's your question, Mariam? Workshop during the weekends. Sure. What I need is really to know when you're available. So if you go ahead and email me also from the class, send the available time. That goes for everyone. If you want to have workshop during weekends, email me from class and give me some ideas, the time slots that you can be available, and I'll do my best to arrange it. That would accommodate most of you or all of you. So let me know. All right. If everybody okay with everything, you can. Okay, you're welcome, Maria. You can just type bye, that I know you're okay, and you click on the door out, and you'll be out of the room. And I'll see you next time. Keep looking for the class announcements for the next available workshops. Also check your emails every morning, please, because some of these workshops, when they're available, I will email you, so you need to check your emails regularly. All right, thank you.